All right, so today we're doing more with circles. Apply other angle relationships in circles. So here we go. We're starting right out with theorems with lots of space for a drawing. You ready? All right. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. This is really the same as an inscribed angle and its intercepted arc measure. It's really the same. But let's just draw a picture. So draw a circle. That's really not very pretty, but that's okay. Draw a tangent line. I'm going to label that A. Tangent is a line that hits a circle at one spot.
Tangential.
Oh, tangential?
What is that?
It has to do with the line, a tangent line. It's nothing fancy. All right, I am going to draw a chord like this, a little bit on an angle there. Label that B. And then because we have to name arcs, I'm going to just put C over here because this is a major arc. So now, label this angle 1 and angle 2. And we're going to write a sentence about what they're saying here. So they're saying that the measure of angle 1 here is equal to, the measure of each angle formed is 1/2 the measure of its intercepted arc. So it's the same thing as an inscribed angle. It's really not any different. Okay? And then the measure of angle 2 is 1/2 of, however you want to label this arc. I'll just say ACB. It's an arc. So that one's not all that different than an inscribed angle. It's the same thing, basically. They're arcs. They're arcs. Arcs.
The line above 8 looks like a
You never know with my writing. It is an arc, okay?
Wait, are you left-handed?
Yes.
I didn't know that.
Does that explain everything, Jill? Seriously? Here we go. Let's do the next theorem, okay? Moving on. Here we go. If two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Wow, let's just talk a picture. Draw a picture. Let's draw a picture. So I have an arc here. Let's label that AC. And then I have another arc here. We'll label that BD. So two chords intersect inside the circle. Then the measure, well, let's label this angle 1 and this angle 2. So we're gonna write an equation for both of those measures. So we'll start with the measure of angle 1. Is equal to, ready? This one's kind of weird. 1/2 of this arc plus this arc. So if you read it, it says the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So it looks like this. 1/2 the measure, I should have put an M up here and I didn't. The measure of arc DC, that is an arc, not a line. And the measure of arc AB. So basically, if you have two chords intersect inside the circle, you can find that angle measure by taking 1/2 of these two arcs added together. Okay? So let's do the same thing for the measure of angle 2. Is equal to 1/2 the measure of arc BC and the measure of its vertical angle arc, which would be arc AD.
Would it just be times 2 then, technically? It's a vertical.
No, because these are not on the center. So these angle measures will not be the same. These, yeah, but the arc measures might not be the same. because it's not on the center. Should be. You're right. I don't know. That's a good question.
Okay, I don't know what word.
Yeah, if they're vertical angles. But I don't know. I got to think about that one. I can't say for sure. I have to look. It's a good question. All right. In 10.13, are you ready? If a tangent and a secant, or two tangents or two secants intersect outside a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. We're going to take a little bit of time and draw all three of these. Pretty much they're the same idea, but I just want you to see what they all look like. So draw a circle over here. It says a tangent and a secant intersect outside the circle. So I'm going to draw a secant. Label that A and B. And I'm going to draw a tangent and label that C. What this says is, if a tangent and a secant intersect outside the circle, which they do, then the measure of the angle formed, that's this angle right here, angle 1, is 1/2 the difference of the measures of the intercepted arcs. So between these two right here, here's an intercepted arc, and here's an intercepted arc. So we would write it like this. The measure of angle 1 is equal to 1/2 the difference of those two arcs. So here we're subtracting instead of adding like we did here. Now, would you subtract the smaller from the bigger?
No.
No, because you don't want a negative angle, right? So do the bigger one minus the smaller one. Oh, arc, arc, arc. Okay, let's do the next one. We're going to do two tangents now. It's really the same idea, but it just looks a little bit different. That's two tangents. We're going to put a Q here because we have a major arc that we're talking about. We have to label. So again, it's the same idea. We have two intercepted arcs. We have this one and this one. So you would do the same. Let's say that's angle 2. The measure of angle 2 is equal to 1/2 the measure of this arc, because it's bigger. And not angle. Why do I put angle? I'm sorry. I should not put angle.
I didn't even notice.
Ah. Say it. PQR minus the measure of arc PR. So we'll just draw this last picture. We probably don't even need to write it, but let's just see what it looks like. So the last one says two secants. Okay, so we have a point outside the circle, and we have two secants. So we'll call that W, X, Y, and Z. So the measure of angle 3 here would be equal to what? This arc, half of this arc minus that arc, right? Same idea. Do we need to write it down?
Yeah.
Go ahead if you want. You can write it down. Okay. Okay, turn it over. Let's just practice some of these ideas. Line M is tangent to the circle. Find the value of the variable. Okay, well, it's really the same idea as the inscribed angle. This is from Theorem 10.11 on the other side. Theorem 10.11. This is going to be half of its arc that it's formed, intercepted arc. So it would just be x equals 1/2 228, and x equals 114 degrees. That's it. For that, yeah. This one here, I know it's the same idea as the inscribed angle. So here's the angle measure. We need y. It's just going to be what?
It's the same thing, but just
Y equals 2 times 118. 236 degrees.
square.
You with me, Annie? Here they gave us the angle measure, and we need the arc measure. It's just 2 times the arc. 2 times the angle, okay? All right, so here we're going to that last theorem that we just drew pictures of. So they intersect outside the circle. So we need angle x. So this is theorem 10.13. If you're curious, I should just not do the E there. The 10.13. Anyway, all we do is it's very simple here. You just say, all right, well, x is equal to 1/2 of this bigger arc, 78 minus 42. Because it's outside the circle, it's minus.
I'm gonna guess.
And x equals 18 degrees. And then cut it in half. Yeah. All right, what's the difference between this one and this one?
Let's say
It's inside, so you add instead of subtract. You add the intercepted arcs. So here, x would be equal to 1/2 89 plus 63.
equals 152. 25.
Now,
It'll be 76.
I find this interesting because this kind of goes back. Here we go. The space shuttle typically orbits at a height of 600 kilometers. Shh, please pay attention to this. You're going to be lost. Suppose an astronaut takes a picture from point S. What is the measure of arc RQ? So we need this arc right here. Now, this is the center of the Earth, right? From the center of the Earth, they're saying, to the surface is 6,370 kilometers here. Then they said this from the center of the Earth to the space shuttle itself is 6,970. Where does that number come from? You see it? From here to the surface of the Earth is 6,370, but they're saying from the center to the space shuttle, if it was right next to if it's going around the Earth like this, is 6,970 because they added 600 to it. So they've already used the 600, is what I'm trying to say. They've added it in here. Okay? So that's one thing we can see. What else do we know about this picture? We need to find this arc measure. So perhaps if I find this angle, I can easily state that arc measure, correct? You have the skills to do that. Let me show you how. First of all, we see that it's 2 right triangles, correct?
Right.
One of the theorems we learned is a point that is tangent to a circle in both of these directions, and we see this here. We know that this piece is congruent to that piece. We learned that. Right? We also know that since they share the hypotenuse, that's reflexive, correct? Oh, therefore, these 2 triangles must be based on HL. Remember HL? Hypotenuse leg. Let's write that down. 2 tangent lines. I'm just going to kind of write down our reasoning here. I know SQ is congruent to SR because tangent segments from a common point that are equidistant. And do you remember that one? Tangent segments from a common point are congruent. Then we also know that SP is congruent to SP by reflexive. I'm getting to the point here. Just be patient.
That's fine.
I know. So therefore, triangle PSQ is congruent to triangle PSR by HL. The reason I did that is because if I can find this angle right here, I can double it and have the measure of angle P, right? Well, we learned how to find unknown angle measures in right triangles if we have two sides. What do we use? Right on.
No.
Because we have this measure and we have this measure, don't we? So we have a leg and we have a hypotenuse. So we use the inverse to find the angle measure. So are we going to use cosine or sine?
Let's say sine.
No.
Let's say
Sine is opposite over hypotenuse. We have adjacent over hypotenuse. So we're going to use cosine inverse. 6370 over 6970. And when you go to your calculator, it gives you that angle measure, which is 24 degrees. Now, is that the measure of angle P?
No.
No, what's the measure of angle P?
48.
48. Because these are congruent, I can double that. So the measure of angle P is equal to 48 degrees. Because we double it. Therefore, the measure of arc RQ is what?
48.
90.
48. 48.
I can't think.
Now, that's one way to look at it. Could we use something else?
No.
Of course we could.
No.
We could use this one right here, couldn't we?
Why did
I
we
think. I don't know if that would even help us. No, I don't think so. I don't know. Come on. Come back.